So now we know how to store the data within an array list. But of course, whenever we have some data in an array list, it's always nice to have it sorted in some way. Well, this is very simple when we are talking about some primitives, some integers, some numbers essentially, but when it comes to objects, it can get a little bit complicated. So let's talk about that. Just a disclaimer, this is the third video in series about data structures and collections within Java, so if this is the first one that you are seeing, then please head on to the link in the description to the playlist to start at the beginning. But yeah, let's then tackle the topic of sorting out an array list and how to properly do it. Let's start by creating a class that we'll be using that we'll want to get sorted out. Let's call it a transaction. So essentially, this will be a class that will hold information about a transaction, right? So we need a description that will be held within a string. And we need, let's say, a double amount. Let's use IntelliJ Magic to generate a constructor, generate a getter and setter. Okay, so now we've got our transaction class. And right now what I would like to do is I would like to sort by the amount. And how can I go about it? I could, first of all, create a method that would just sort the transactions using the amount. But it's pretty cumbersome, I don't want to do it, and I would need to do it for every other field that I would like to use. There are some other ways that I can achieve this exact same scenario, right? First of them is the comparable interface. So let's add the interface to our transaction class by using a keyword called implements comparable of transaction. And now what we need to do. So we'll talk a little bit about polymorphism, interfaces, and extending classes a little bit later on in the course. But right now, what it's actually telling to you is that this transaction will be comparable to other transactions, so all the classes, and we'll be able to sort it, right? If we implement an interface, it means that we need to implement all the methods of this particular interface to get rid of this red line. So in order to do that, I just use Alt-Enter, implement methods, and I got this compare to. What actually it means and what it says. This is actually a method within the comparable interface that I can go to the interface itself to read the documentation of. So yeah, long text, very, very long. Essentially, it means that this interface imposes a total ordering on the objects of each class that implements it. Meaning that if we have this implemented, then we can order the transactions that we have in order that they should be. So the largest amount at the top, the smallest at the bottom, right? But here we've got this mysterious method called compare to with transaction O. What actually it means is that if I have this transaction here that will have a specific amount when it's created, then I will use this compare to method to compare it with other transaction that is in my array list to be able to tell which one is bigger. The field that I want to use is the amount field. So in order to be able to use the amount field, I just need to use a pretty useful method, double compare that amount, so the amount of the object where I'm at, and O that amount, where O is just the transaction. So we can just call it transaction. So yeah, this way, whenever we are doing a comparison, we'll be comparing the amounts that we have in this class. So let's see how it performs in action and essentially whether this is already it or do I need something more. Spoiler alert, it is already all that I need to do in order to be able to actually implement this. So now let's go into main.java. Let's delete this line of code and delete this breakpoint because we won't be needing this. Let's create a new list of transactions, new array list, and then let's add there some transactions. I'm gonna use some anonymous transactions, meaning that I do not first provide a variable for them. First 1.0 and just do it like so. And we're gonna add, let's say, 3 of them. Okay, then I'm gonna put 5 here and 1.2. And let's print out our transactions array list. And yeah, I've got my transactions, but they are pretty ugly. So what I can do to combat that is I can just go back into the transaction class, add insert, and then just generate a toString method that will essentially give me information about the object that I would like to have. We'll dive a little bit deeper into what exactly the toString method is, where it comes from, etc. a little bit later when we are talking about extending some classes. So let's try to print this out again, and we can see that the ordering is as full as essentially the items were put into our array list. So let's try and sort it out. In order to sort it, we need to use collections.sort and use as a parameter our array list. And we can only use it here because the objects that are within the array list are comparable. If we go into the sort method, we can see that it only gets lists to be sorted and sorts the specified list into ascending order according to the natural ordering of its elements. All elements in the list must implement comparable interface. If we did not implement the interface, we wouldn't be able to actually do the sorting over here. So let's go ahead and use it. Oh, sorry. First of all, we need to check the result of our sorting. So let's see how it goes. And yeah, here you've got the first without sorting. So 1.0, 5.0, 1.2, and now we've got it sorted out, 1.0, 1.2, 5.0, meaning that I don't need to really implement any sort of a sorting mechanism for it, and everything just works out on its own. So that's very, very nice. But if I wanted to check whether I can sort with some other field, for example, I've got transactions, dates, descriptions over here, then I would first of all need to change the compare to method, right? It's not something that I really want to do, to write many implementations of the compare to method. First of all, I can't really do that. The compare to method will be only one because it's due to the implementing interface and we can't do much more. So in order to avoid setting up some complicated implementation within this method, what I want to do is create a comparator, meaning that it will be a special class that will tell the sorting algorithm to not use the compare to method, but rather use the one that I'm going to show you just now. So let's put a new Java class, which is going to be called transaction name length comparator, because we will be using the length of a name as a field that will be actually something that we use for the comparison. Implements comparator. So this is a special tool that we'll use then to actually sort out our transactions. So let's implement methods. And here we've got two transactions, O1 and O2. This time there are two because I'm not in the context of a transaction anymore and I cannot access that amount, right? That I could usually in the transaction class. So here we've got this compare method and we've got O1 and O2. So what I want to do is run integer.compare. Easiest way to do it, right? Because at the end of the day, the compare method returns an int value, a whole number, -1 if the object is smaller, 0 if the objects are equal, or 1 when the objects are bigger. So this way it's very, very simple to understand all about what's going on. The field that we want to use is going to be the length of a description. So let's get description dot length and then O2 get description dot length. And then just compare those and tell me which one is bigger. If we go into the implementation, we can see exactly what I have said. If x is smaller than y, return -1. If they are equal, return 0. If not, return 1. So very, very simple. But now that we got our comparator, let's see how to use it. Let's go back into our main Java. And here we've got a different ordering, right? So let's see how this is going to behave a little bit. Let's put the first one as a bit larger one so that it's going to be different. Yeah, okay. So now, instead of doing collection sort transactions, we've got this information that it sorts according to the amount that we have in the comparable interface. But now let's do collections that sort. This time we are going to, of course, put in the transactions list, but we are also going to get here a new comparator that we have just created. And now, with that being said, let's compare the lists before and after both sorting. So yeah, here you have it. We've got our unsorted list, then we've got sorted by amount, and then last but not least, we've got sorted by the length of the description field. So pretty powerful tool that we can use on multiple occasions. So to sum it up, comparable interface is required to use collections that sort mechanism, and it actually tells you how to compare a field between two transaction objects or any other object that you create. You can treat it as a default sorting algorithm, or rather values for your class. And the comparator is to be used whenever you've got something else that you want to sort by, but do not want to change the initial code that you have created. With that being said, thank you very much for watching. I will see you in the next video, where we are going to be tackling some things around equals, hash code, and some other very, very fascinating things around collections and storing data within Java. Thank you very much, and see you then.